Okay, we're moving now into homework set 32. I've got 3 problems lined up for you. They are in the homework set that's primarily on page 467 with some applications that follow that. This is another set of pages that you really need to spend some time on, because you're now at the point where we've worked through all the properties of the 6 basic trig functions. We've worked through the properties of the arc functions associated with those 6. We've developed some identities, and now we can bring all that to bear to solve some equations which involve trigonometric expressions. And this is this is really where the STEM majors, you majors who are looking towards engineering or scientific degrees, this is where you're trying to get. You're trying to solve trigonometric equations, because later in life you're going to find that maybe some of the things that you're working with in your field, whether it's physics or mechanical engineering or electrical engineering, or for all I know, biology, are going to be, those physical principles are going to be modeled by trigonometric equations or trigonometric functions, and relationships are going to find themselves represented in trigonometric form, and you're going to end up having to solve equations. Maybe some equations like this we'll see. So this problem, again, 79, your sister problem 78, says solve the following: tangent squared of theta is equal to 3/2 secant. Find me an answer, or find me the answers that fall between 0 and 2 pi. And you're going to quickly see that there's going to be more than one answer here over that range, and the problem says find everybody. So what to do? We've got a tangent squared and a secant. The good news is that we're only dealing with trigonometric functions with an argument of theta. Later, that won't be the case, and we'll have to kind of line them all up to be the same argument before we can do anything. But what might we do here? There's a lot of different levels of difficulty in trigonometric equations. And the first is, things get difficult when you've got different types of trigonometric functions involved. We've got a secant versus a tangent. And you really need to find a way to turn everything into tangents or everything into secants. So that statement has to trigger in your mind, there is a relationship that I know between tangent and secant, and it's one of the Pythagorean relationships. The one that you just have to wake up in the middle of the night and be able to spout out is that the sine squared of theta plus the cosine squared is equal to 1. But to me, that one gives birth to all the others. All I have to do is divide everybody through by cosine. I get sine squared over cosine squared is the tangent squared of theta. I get cosine squared over the cosine squared is 1. I get 1 over the cosine squared is the secant squared of theta. All right, so there's a relationship between tangent and secant. What I'm going to do is solve for tangent squared. It won't take long. Tangent squared is equal to secant squared minus 1. And now if I insert this in for tangent squared, I'm going to have something that just is in terms of secant. So to celebrate that, let's change colors, and let's say, okay, instead of solving that, let me solve the following: secant squared theta minus 1, aka tangent theta, is equal to root 3 over 2 secant theta. All right, let's just shake it off, because we've done a lot of work and we don't have a solution yet. But now I've gone from a situation where I've got an equation that involves 2 different trigonometric functions to one that involves 1. Well, that's better. Can I solve it? Yeah, I can, when I recognize that, look at that thing. That's a quadratic in secant squared. If you allow me to just line it up here. This equation becomes this equation. And if you would rather, let's just say, let's let u be equal to secant theta, then this equation becomes u squared minus 3/2 u minus 1 equals 0. And come on, it's a quadratic equation. We can solve that in a heartbeat. My biggest problem here is I'm kind of running out of space. I'm going to change colors again and try to jam this in up here now. Let's see, we've gone from here to here, up to here. No telling where we're going to end up, probably right down at the bottom where I always end up. So let me solve this using the quadratic formula. Opposite of b plus or minus the square root of b squared. Oh God. 9/4 minus 4 times a times c, which is a minus 1. Good, good. Ooh, this is all good. Take the square root, divide by 2a. And let me just do this in my head. I hope this did not fall off the page, but this says 9/4 plus 4. So let's make that, that's terrible. Really? Let's do something. Let's make this 16/4. So I've got 9/4 plus 16/4 is 25/4. I'm going to just carry this down now. 25/4 divided by, to the 1/2 divided by 2. 25/4, when you take the square root, is going to return plus or minus 5/2. So I've got 3/2 plus or minus 5/2 all over 2. All these 2's, no, these 2's don't cancel, do they? This turns into 3/4 plus or minus 5/4. And now I've got two answers. The first one is 3/4 plus 5/4, 8/4, or 2. And 3/4 minus 5/4, or minus 2/4, or minus 1/2. I would like to put a circle on this, but we're not interested in u. We're interested in theta. Yep. So now I've got this. So secant theta is either equal to 2 or to minus 1/2. And you know what? I'm going to kind of give up here, I think, and just erase something to to give us some room to deal with this very last part of this problem. Because now we've got to find the angle whose secant is 2, which is not going to be hard for the following reason. What's hard about it is I hate to give anything up, but I'm gonna. There, it's gone. Okay, let's solve this problem now. What is the angle whose secant is equal to 2? Well, that's the angle whose cosine is equal to 1/2. And now, where between 0 and 2 pi is the cosine equal to 1/2? Heck, where is it not? Right? Because here comes the cosine. Here is 1, so here is 1/2, and there are two values here where it's equal to 1/2. And if you will, the first one is 60 degrees, right? 60 degrees, so that's 2 pi over, it's pi over 3. If you want to verify that, we'll draw a quick little triangle here. That is, got theta equals 60 degrees, this is 30 degrees, this is 1, this is 1/2, this is root 3 over 2, and sure enough, the cosine of 60 degrees is 1/2, that's what we're looking for. And then this one is 60 degrees shy of 2 pi. 2 pi minus pi over 3. This is 6 pi over 3 minus pi over 3. This is 5 pi over 3. This is 5 pi over 3. This point right, this value right here. This value right here. So there's two answers. Let's go, how many answers can I get? I'm looking back at your book here. Yeah. So now let's look at secant of minus 1/2. Secant of minus 1/2. So let's solve secant of minus 1/2 here. Minus 1/2. And that means we're looking at cosine theta of -2. And we can stop right there because -2 is not in the range of the cosine. There is no theta that produces that. So at the end of the day, we've got two answers. They are pi over 3 and 5 pi over 3. Yeah. Yep, so there you go.